All right, our next circle lesson is on inscribed angles and arcs. And so an inscribed angle, like it says here, is an angle whose vertex is on the circle, on the outside of the circle. So if you look at this diagram here, the angle at point B here, angle ABC, is going to be an inscribed angle because point B, the vertex, is on the circle. And one thing it tells you here is an arc created by an inscribed angle is twice as large as the angle itself. So say this angle right here, angle ABC, is 62 degrees. If you want to find the arc, and one thing really quick, there's a second vocabulary term here that's important, and we probably should have covered this in central angles, but we have this term intercepted arc. So when you have an angle on a circle, whether it's a central angle or an inscribed angle, and you follow the sides of the angle all the way out until it hits the circle, that arc that it creates between the 2 points is called the intercepted arc. So when an angle creates an arc on a circle, that's what it's called, the intercepted arc. So AC, arc AC is the intercepted arc. And to find the measure of that angle, or that arc, in degrees, you would take the 62 degrees and you would just double it. You multiply it by 2. So this arc, AC, is going to be 62 times 2, which is going to be 124. So it's a 124 degree arc. So we'll talk a little bit on the Google Meet about why that is, but just remember that if you have an inscribed angle, so the vertex is on the circle, and you follow the angle out to the other 2 places where it hits the circle, and you look at that arc that it creates, the arc will always be twice as big as the original inscribed angle. So on your assignment, you're going to have a few questions like this. It says, determine whether each angle is inscribed. If so, identify the intercepted arc. So if you look on the first example here on the bottom left, the angle is right here at point C. So the angle is angle BCD. And first question is that an inscribed angle? And the answer here would be yes, because the vertex, point C, is on the circle. So this would be yes. The second question is, what is the intercepted arc? So if we look at this angle here, again, I'm going to follow it out to the points where it hits the circle, and that's at B and D. So this is the intercepted arc right here between those 2 points. So we would label it BD, and we'd use our little arc symbol over the top. So you're going to get some questions like that, and that's how you answer it. You look and see, is the vertex on the circle? If it is, then it's a yes. Then you follow the two sides of the angle out to the other 2 places where the angle hits the circle, and the arc will be between those 2 points. If you look at the second one here on the right, the vertex of this angle is at R. So this angle is QRS. But if you look at where the vertex is not touching the circle. It's inside the circle. It's not on the circle. So this is going to be a no. This is not an inscribed angle. And that's going to be important because inscribed angles have properties that other angles and circles do not. So the second one would just be a no, and you don't have to do anything more than that. All right. And the rest of the stuff you're going to be doing with this is using what we know about inscribed angles to find the measures of different things. So here's a good example. They give you this circle. You've got 2 angles here. You have this angle at ADB, which is an inscribed angle because point D is on the circle. You have another angle DBC, which is also inscribed because point B is on the circle. And it asks you 2 questions. It wants you to find the measure of arc DC and of angle ADB. So let's start with arc DC. And I'm going to write this with the little M in front to say measure of arc DC. And so if you look at arc DC, find those 2 points and make this little arc. That is an intercepted arc created by the angle DBC. And we know that because if you start at D and follow the line back until you hit the vertex, start at C, follow that line back till you hit the vertex, then this angle right here, this 45-degree angle, is the angle that when you extend it, creates this arc DC. So now what you want to do to figure out the measure of DC is you take that angle, 45 degrees, you multiply it by 2, because you always take your inscribed angle, multiply it by 2, and that's going to tell you the measure of the arc. 45 times 2 is 90. So arc DC has a measure of 90 degrees. All right, the second thing we're trying to find is the measure of angle ADB. And so that ADB, we're just going to trace that angle, start at point A, go down to B, and then back out to B, and it's this angle right here. Well, if you look at that angle, at the 2 places it hits the circle over here, A and B, it creates this arc. And we know that this arc is 76 degrees. So this time we're going backwards. So the first one, we took the angle, the inscribed angle, multiplied it by 2, and that told us the arc. Here, we know the arc already, and we want to find the angle, so we're going to go the other way. We're going to divide by 2, because we know that the arc is twice as big as the angle. So we're going to take 76, divide it by 2, and if you take 76 and divide it by 2, you will get 38. So you'll get 38 degrees. So that tells us the measure of angle ADB is 38 degrees. So basically you're multiplying or dividing by 2 is the idea. But as always, these can get more complicated. So let's keep going here. Little bit more complex diagram here. And we've got 3 things we want to find. We want to find arc PN, arc NML, and angle LNP. So let's start with arc PN. So PN, we're going to find the 2 points, P and N, and connect that. And so there's a lot going on at both these points. There are 3 different line segments that hit point P and 3 different line segments that hit point N. So what we want to do is we want to see, can we match that arc PN up with an inscribed angle that we already know? And if you look at this diagram, there's only one inscribed angle we know. It's this one right here at point L. So what we want to do is see, can we trace these 2 points, P and N, back to point L? So what I'm going to do is I'm going to start at point P and draw this line to point L. Do the same thing with N. And notice that when we do that, it takes us back to this angle, which is 68 degrees. That's an inscribed angle. So to do the measure of arc PN, we're going to do what we did on the last slide. We're going to take the inscribed angle, 68 degrees. We're going to multiply it by 2. And when you take 68 multiplied by 2, you should get 136. So 136 degrees is this arc right here. And I'm going to go ahead and put that on the diagram because we might need that measurement to find some of the other stuff here. Second thing is arc NML. So that's a 3-letter arc, and that just tells us, because if you're going from N to L, there's 2 ways to get there. And so here it's telling us we want to go through M. So NML, we're going this way. It's this arc. So our points this time, and you know what? Let's color code this so it's a little more clear which stuff I'm referring to. Let's do this in orange this time. So we're starting at N. We're going around the circle through point M and over to point L. So N and L are the 2 points on the ends of this arc. And again, we want to trace these back to an inscribed angle. So if we do that, if you follow these 2 points back to an angle, really the only place you can go is down here to P. And so we get this angle right here. Now, the problem with this angle is we have no information about it. So we can't do the same thing we did for arc PN. We don't have an inscribed angle to use. So now we got to kind of look at the circle and see what else we know. Well, here's one thing we know. We know that the green arc down here is 136. This other piece over here on the left is 92. And then the only other part of the circle that's not already covered by the 136 or the 92 is this orange arc that we are looking for. So here's what we can do on this one is we can say we can find the measure of arc NML by using this equation. We can say, well, 92 plus 136 plus this angle that we're looking for, this arc, that we're looking for, those three things together make a full circle, so they have to add up to 360. So we can solve this equation and figure out the length of our arc. So 92 and 136, when you add those together, you get 228. And we can just subtract that from both sides. And when you do that, you get x is equal to 132 degrees. So the arc that we're looking for here is 132 degrees. All right, so we know the green arc is 136, the orange arc is 132. We also have that 92 degree arc from L to P. So our last thing, it says it wants angle LNP. So I'm going to switch colors one more time. So this time it's not an arc, it's an angle. It's angle LNP. And I'm going to write that over here. Measure of angle LNP. So I want to find that angle. So I'm going to start at L. I'm going to go to N and then out to P. So I've traced that angle in purple. It starts at point L. It goes to a vertex at point N, and then it comes out to point P. So it's this angle right here. That's what I'm trying to find. And when I look at this, I can see it hits the circle at L and P, and it makes this arc. This is our intercepted arc. And we already know that's 92. Now remember, if we know the arc and we're trying to find the angle, we're dividing by 2 because the arc is always going to be bigger than the inscribed angle. So we're going to take 92 and divide it by 2. And when you do that, you're going to end up with 46 degrees. So this arc right here is 46 degrees. So it's just, and you're not always going to have to find this many things with one diagram, but you're going to have to kind of mix and match things that you know to try to figure out how to get the piece of the diagram, the angle or the arc that you're looking for. So, but if you look at this, to find these three things, there was 2 things we knew. We knew that an inscribed angle is half as big as the intercepted arc it creates. So if we want to go from the angle to the arc, we multiply by 2. If we want to go from the arc back to the angle, we would divide by 2. And the other thing we knew is that the total number of degrees in a circle is 360. So with those 2 pieces of information, we were able to find all this stuff. And we could keep going and find other angles if we wanted to, but we're going to go ahead and move on here to our next set of examples. Okay, now we're going to bring a little bit of algebra into this. So here we've got quite a bit going on in this diagram, and it asks us to solve for x and y, and then to use that information to find the measure of 2 arcs, arc AD and arc BC. So I'm going to start with x. There's 2 angles here that have an x in them. The first one is up here at point B, and this is going to be angle ABD. And so this is an inscribed angle, and if you look at where it hits the circle, when you follow it out, it hits at A and it hits at D. So it creates this arc right here, AD. The other angle that has an X is over here at point C. And when you follow this angle, it's going to be angle ACD. And what you'll notice about the second angle is it also hits the circle at A and D. And it also creates that arc. So you have 2 angles that create the exact same intercepted arc. They both give us arc AD. Now what we know is the arc AD has to be twice as big as the inscribed angle. So arc AD has to be twice as big as this angle up here at B. It also has to be twice as big as this angle up here at C. And what that tells us is that angle B and angle C have to be exactly the same. They've got to be congruent to each other. So we're going to take that information, the two angles that form the same intercepted arc, two inscribed angles that give us the same intercepted arc have to be congruent. So we're going to say 6x minus 3 is equal to 7x minus 11. And we can work that out. I'm going to start by subtracting 6x from both sides because I know that's going to give me an x on the right side. Still have minus 11. Over here on the left, I still have a negative 3. Now all I have to do is add 11 to both sides. And I get that x is equal to 8. So I know x is equal to 8. All right. Now I'm going to go ahead and find y, and then after we've got y, we'll find these two arcs. So I'm going to change colors again. So I have two angles that have a y in them. I've got this angle right here, which is 6y minus 2. That angle has a vertex at A, and when we follow it out, we see that it hits the circle at B and C and creates this arc right here. I'm going to take my second angle that's marked with a y. It's this angle right here at point B. I'm going to follow it out. And just like what happened with the x's, these two angles both give us the same intercepted arc. They both take us to arc BC. So again, just like the two x angles, the two y angles have to be congruent because they give us the same arc, the same intercepted arc. So we can say 6y minus 2 is equal to 5y plus 8. And again, I'm going to start by subtracting the smaller term that has a variable. So I'm going to subtract 5y from both sides. And that's going to give me y, or 1y, minus 2 equals 8. So now I'm just going to add 2 to both sides, and we're going to get y equals 10. So x is equal to 8, y is equal to 10. The last thing we've got to do, or the big thing we're trying to figure out here, is find the measure of these two arcs, arc AD and arc BC. So if you look at arc AD, that's marked in green. So we got that from the two angles that had x in them. So it's this arc right here. So what I want to do is I want to pick one of those angles, and it really doesn't matter which one. Let's take 6x minus 3. I know that x is equal to 8. So I'm going to plug 8 in for x and work this out. 6 times 8 is 48, minus 3 is 45 degrees. So this angle right here at B, angle ABD, is 45 degrees. What I'm trying to find is arc AD. So this goes back to the very first slide, and the very first thing we learned about this is to get the arc, you take the inscribed angle and you double it. You multiply it by 2. So the measure of arc AD is going to be equal to that 45-degree angle times 2. So it's going to be 90 degrees. 45 times 2 gives us 90 degrees. All right, let's do the same thing with arc BC. You'll notice arc BC is marked in orange, and it's the arc created by both of these angles that have y in them. So I can take either angle and plug in my value of y and work this out. So let's take the 5y plus 8, and we're going to plug in our value of y, which was 10. So we have 5 times 10 plus 8. That's going to give us 50 plus 8, which is 58. So this angle right here, angle CDB, is 58 degrees. And so to get my arc, again, I'm going to take my inscribed angle and multiply it by 2. So to find the measure of arc BC, I'll take my 58-degree angle, multiply it by 2, work that out up here, and I'm going to get 116 degrees. So You will have to do a little bit of algebra on this lesson. What you want to look for is things you know are equal to each other. If you can set things equal to each other, it's going to allow you to solve for your variable. And then after you solve for your variable, it's just a matter of plugging it back in and using the rules that you already know. So this is arcs and inscribed angles. Make sure you look at the assignment before our next Google Meet, so that way you can bring any questions you have and we can go over.